Ever feel like AI is just this black box? Super complex, and it feels impossible to know what's really going on inside. Well, today, we're going to pry that box open. We're going to tackle this whole sprawling world of AI not as a bunch of code, but as a story, a creation story. Yeah, that's the big question, right? And we're going to answer it by doing it. We're going to build our own digital human, piece by piece. And we'll use analogies that'll make all those confusing terms finally just click. All right? You ready? Let's get into it. Okay, so here's the plan, our blueprint. First, we lay out the core idea. Then we actually build the brain. After that, we've got to give it an education, connect it to the world so it can do stuff. Install a conscience, super important, and finally, run a few checkups to make sure it's healthy. All right, first up, the blueprint itself. The whole idea here is to use this single analogy, building a person, to create a really clear picture of how all these different AI pieces actually fit together. Every creation story has to start somewhere, and for us, it starts with the mind. So let's get to the most important part right away, building the brain of our digital being. Okay, let's tackle the big one first, AI itself. What is it? Well, in our analogy, it's not really a body part. Think of it more like the life force. It's the spark of sentience that makes the whole thing, well, alive. So if AI is the life force, then what's the brain? That's the large language model, the LLM. This is the physical thing, the cerebrum. It's this dense, powerful engine, just packed with connections. This is the absolute core of our digital human's mind. But what's this brain actually like? Well, it knows a ton of stuff. It's got all this general knowledge from its childhood, which is what we call its pre-training. But, and this is a huge but, on its own, it's basically a brain in a jar. It can think, sure, but it can't do anything. It can't interact with the world. It's just pure, untapped potential. And this brain isn't just a boring encyclopedia. Nope, this is where generative AI comes in. Think of that as its imagination. It's the magic that lets it take all that knowledge and create something brand new. Write a story, whip up some music, or just dream up a crazy image. It's that creative spark. Okay, so we've got a brain, and it has an imagination. That's a great start. But for it to be actually useful, it needs to go to school. It needs to learn, to specialize, and of course, it needs to remember what it's learned. Right. So you can think of the basic LLM as having, say, a really good college degree. It knows a little bit about everything. Fine-tuning, that's sending it to grad school. We take that brain and just immerse it in one specific subject, like feed it nothing but medical textbooks, until it becomes a true expert in that field. But hey, even the biggest expert doesn't know everything, right? I mean, if someone asks you a super specific, up-to-the-minute question, what do? You look it up. And that's exactly what RAG is. It's like giving our AI an open book test. It can go consult a library or a database to get the latest info, instead of just trying to remember it all. So let's just make sure this is crystal clear, because it's a really important difference. Fine-tuning is about becoming the expert. You're actually changing the brain, making it internalize all this new knowledge. RAG, on the other hand, is about having access to an expert. It's giving the brain a library card. One rebuilds the brain, the other just gives it a new tool. See the difference? And of course, what good is learning if you can't remember anything? So we have to add memory. This gives our digital human short-term memory, just to remember what we're talking about right now. But it also gives it long-term memory, so it can remember our past conversations. That's how you get a really personalized experience. All right, so where are we? Our digital human is educated, it has a memory. But it's still just a brain in a jar. It can't do anything yet. So now it's time for the really cool part, connecting that brain to a body, giving it a nervous system so it can finally take action in the real world. And this is where AI agents come into play. What's an agent? It's the part of the brain that's all about willpower, the drive to actually act. It's the executive function. It can look at a big, complicated goal, break it down into smaller steps, and then figure out a plan to get it done. This is what turns our passive little thinker into a real go-getter. So let me walk you through how it works. You give the agent a goal, something like, hey, plan a trip to Paris for me. The agent then thinks, okay, what do I need to do? And it makes a list. First, check the calendar. Then, find some flights. After that, book a hotel. Oh, and reserve a table at a nice restaurant. It figures out what tools it needs for each of those jobs, and then it just does it, all by itself. But how does the brain talk to those tools? How does it actually book the flight? Well, that's where its central nervous system comes in. And in the AI world, that's LangChain. Think of it as all the wiring. It's the network that connects the brain to its hands and eyes, and that library we talked about. It's literally the thing that turns a thought into an action. Okay, let's take a step back. We've built something that can think, learn, and act on its own. That's, well, it's incredible. And honestly, it's a little bit scary, right? So the next step is maybe the most important of all. We have to make sure our creation is safe, that it's responsible. We need to give it a moral compass. It's time to build its conscience. One of the absolute biggest problems we have to solve is something called hallucination. This is what happens when the AI doesn't know the answer, but it wants to be helpful so badly that it just makes stuff up. Plausible sounding nonsense. And the scary part isn't just that it's wrong, it's that it's confidently wrong. That makes it so deceptive. So how do we fix that? We install guardrails. This is our AI's conscience. It's that little voice in your head that stops you from doing something dumb, like yelling in a library or giving out terrible advice. These guardrails are a set of rules that just step in and say, nope, not going to do that when a request is harmful or the output could be toxic. But sometimes for really high-stakes stuff, a conscience just isn't enough. You need actual supervision. That's what we call a human in the loop, or HIT. The best analogy is a driving instructor. The AI has its hands on the wheel, sure, but there's a human sitting right there in the passenger seat with their foot hovering over the emergency brake, just in case anything starts to go sideways. Okay, our digital human is pretty much built. It's got a brain, an education, a body, and a conscience. We're almost there. The very last step in our journey is to figure out how to give it a checkup, how to monitor its health, and see what's going on in its head when it makes a mistake. So how do we know if our creation is actually working well? Simple. We test it. In AI, these are called evals, or evaluations. Just think of them as standardized tests or an annual physical. We basically give it a bunch of questions that we already know the answers to, and we grade it on accuracy, speed, safety, all that good stuff. It's how we make sure it's performing up to snuff. And what happens when it gets something wrong? We need a way to see why, and that's where a tool like LangSmith comes in. It's basically an fMRI scan for the AI's brain. It lets you trace its exact chain of thought, step by step, to pinpoint where it went wrong. You can see every tool it used, every decision it made. So, here we are. We've built our digital human. We can teach it, give it the power to act, install a conscience, and even look inside its mind. Which brings us to the biggest question of all. Now what? What are we going to ask it to do next?